What is it about the properties of a barely visible waterweed called spirulina that have got even President Obama's family so interested? In 1974, at the United Nations World Food Conference, it was announced that spirulina is the most ideal food for mankind. The World Health Organization has declared that spirulina is mankind's best health product in the 21st century. UNESCO has concluded that spirulina is the most ideal and perfect food of tomorrow. The US Department of Agriculture has published Spirulina Food for the Future, and it has been proposed by both NASA and the European Space Agency as one of the primary foods to be cultivated during long-term space missions. In 2005, an open letter was published to all governments from the United Nations, urging the development of the technology needed to produce this unique water alga. But what exactly is the blue-green alga called spirulina? It is a simple, one-celled form of alga, reaching sizes of 0.3 to 1 millimeter in length. These cells are able to capture the energy of the sun and utilize the nutrients in their watery environment. Then, through a photosynthetic reaction, the cells produce protein, sugars, fatty acids, and vitamins, as well as all the important minerals our bodies need. Using enzyme pigments like phytocyanin, blue, and chlorophyll, green, as catalysts, spirulina is the major oxygen producer on the planet. How is it that such a small cellular form should contain all the strength of life's vital forces? How is it cultivated and consumed? Why do astronauts use spirulina? And what do scientists report? Is spirulina a likely solution for recovery from malnutrition? And can spirulina really save the planet from the greenhouse effect? Stay tuned to discover Mother Nature's molecular miracle. Since its birth, spirulina has been one of the most important life forms on this planet. But it started playing this vital role a very long time ago. This is our planet 4.5 billion years ago. Earth's nitrogen atmosphere, without any oxygen, was rich in carbon dioxide and methane. Scientists believe that the oceans took shape 900 million years later. The first life forms appeared around 3.6 billion years ago. In his book, The Ages of Gaia, James Lovelock gives an explanation for this long period. Since the young sun was 25% cooler at the beginning of life, the greenhouse effect kept a cooler planet warmer. The oceans were filled with iron, sulfur, and other compounds in solution because there was no free oxygen. The first living bacteria, called prokaryotes, appeared in this inhospitable environment. These bacteria consumed chemical nutrients as the only available food. Some of them used the energy of the sun to make their own food. These photosynthesizing prokaryotes were called cyanobacteria, or blue-green algae. They used light energy to split the abundant carbon dioxide and water molecules into carbon food compounds, releasing free oxygen. A new period began about 2.3 billion years ago. By then, oxygen in the atmosphere may have reached a level of 1%. Methane disappeared from the atmosphere, cooling the planet. Cells with nuclei appeared, formed from communities of individual bacteria living within an outer membrane. These cells were called eukaryotes. The nucleus contained organelles, such as chloroplasts, the green bodies which photosynthesize. This more powerful and complicated life form was supported by the higher oxygen concentration. The blue-green prokaryote bacteria and the green cell eukaryotes are called microalgae. These microalgae colonized the oceans and formed a thin film on the land masses. They kept transforming the atmosphere by photosynthesizing for 1.7 billion years. Planet Earth entered its present phase about 600 million years ago. The level of oxygen increased and finally remained steady at 21%. Our planet finally became blue. Today, these microalgae still cover land and water surfaces. The microalgae in the ocean, called phytoplankton, is the base of the food chain, supporting all higher life and producing 95% of the Earth's oxygen. It is part of the living mechanism that regulates the planet's biosphere. Microalgae, despite its size, played a crucial role in transforming the planet into the beauty and richness that makes up life today. And it can only be seen under a microscope. As James Lovelock describes in The Ages of Gaia, the microalgae carried their genetic information in DNA strands in the cell membrane, and were able to exchange information by exchanging plasmids with another cell. In this way, this organism became essentially immortal. All life on Earth was then linked by a slow but precise communication network. There may be more than 25,000 species of microalgae, living in all kinds of places. Most microalgae live off sunlight through photosynthesis, but some live off organic matter like bacteria. They range in size from a single cell to giant kelp over 150 feet long, like seaweed. These microalgae also play an important economic role. About 70 species are used for food, food additives, animal feed, fertilizers, or biochemicals. There are blue-green microalgae like Spirulina, green algae like chlorella, red algae like Dunaliella, and also brown, purple, pink, yellow, and black microalgae. They are everywhere, in water, in soil, on rocks, on plants. Blue-green algae are the most primitive ones and contain no nucleus or chloroplasts. They do not sexually reproduce, they simply divide. What is the blue-green alga called Spirulina? It is the first photosynthetic life form designed by nature 3.6 billion years ago. It still remains the evolutionary bridge between bacteria and green plants.
Spirulina is a microalga. It belongs to the bacteria and actually to the cyanobacteria. So it is a photosynthetic organism. And this organism has a long history as a food.
The two forms of Spirulina bear the scientific names Arthrospira platensis and Arthrospira maxima. They are free-floating filamentous cyanobacteria characterized by a cylindrical, multicellular, elongated hair-like structure called trichomes. Spirulina's shape is in the form of an open left-hand spiral or helix. Biologists tell us that all the secrets of the universe are hidden within this form. The spiral is the symbol of infinity. Even the DNA molecules form a double spiral. The name Spirulina derives from the Greek word spira, denoting the physical configuration of the organism when it forms swirling microscopic strands. The size of these blue-green filamentous cells varies from 0.3 to 1 millimeter. When the size is big enough, the cells simply divide themselves. Spirulina thrives on warm, alkaline, freshwater bodies. It needs water temperatures between 25 and 40 degrees Celsius, with an optimum of 35 degrees Celsius. At lower temperatures, under 20 degrees Celsius, spirulina dies. The sodium carbonated water must have a high pH, between 9 and 11. Spirulina absorbs sunshine, and then a reaction takes place in its cells. This reaction is called photosynthesis. After this reaction has started, spirulina produces the nutrients in the cell and converts carbon dioxide into oxygen. Strong sunshine and agitated water help this particular type of alga produce more nutrients. Under favorable climatic conditions, spirulina can double its volume and weight every 24 hours. Commercial spirulina is normally produced in large outdoor ponds under controlled conditions. Some companies also produce spirulina directly from lakes. The best quality is produced in closed plants that use geothermal water. As a result, nutrients from water are more easily absorbed. If the water contains heavy metals or pollutive agents from the atmosphere, these will be highly concentrated in the spirulina cell, in which case it is no longer suitable for human consumption. Its blue-green color is due to a coloring substance, the protein phycocyanin, a very powerful antioxidant, as well as chlorophyll, the green coloring substance of plants.
I can say that three are the most important bioactive components of spirulina, difficult to find in other microorganisms or other foods. First of all is one major protein of spirulina called the phycocyanin, from the Greek words phyco, which is alga, and the cyanum, which is the blue. So it is a blue protein with very high antioxidant activity and also a very high anti-inflammatory activity.
So why is spirulina known as superfood? It has 3.6 billion years of evolutionary wisdom encoded in its DNA. This immortal plant contains the 5 major nutrient substances which life needs in order to evolve. In fact, spirulina is rich in proteins, sugars, fatty acids and vitamins, as well as minerals. Protein is a vital element that the majority of living organisms need for their healthy development.
Spirulina has a very high nutritional value, and this because it has enormous amounts of protein. We can say that spirulina is the richest food in our planet as far as protein is concerned. It has a content of about 60 to 70% of the dry mass of the microalgae, which is richer than common foods with high protein amounts like meat, milk, eggs, and soya.
Spirulina has the highest amount and most excellent quality of protein compared to any other natural food. Specifically, there is far more protein than animal meat, 70%, fish, 22%, soybeans, 35%, dried milk, 35%, peanuts, 25%, eggs, 12%, grain, 12%, or whole milk, 3%. The quality of spirulina's protein fulfills the ideal standards of the Food and Agriculture Organization of the United Nations. It is known as a complete protein, since it contains all the essential amino acids. The protein in spirulina is digestible up to 95%, one of the highest available digestion rates.
The various nutrients of spirulina are very easily digested. Why is so easily digested? Because spirulina has the very interesting peculiarity not to have hard cellulosic walls, which make difficult to digest the human body, the various foods.
Besides which, it contains about 13.6% sugars. Spirulina's polyunsaturated fatty acids are 4 to 7%, 3 times more than those of evening primrose oil. The important omega-6 family acids, like gamma-linolenic acid, known as GLA, and the essential linoleic acids can be found in spirulina's cells. Spirulina contains a broad range of valuable vitamins, like vitamin E, the B complex, B1, B2, B3, B5, B6, B9, B12, and vitamins D, H, and K. Its B12 content is between 2 and 6 times higher than that of raw beef liver. It is a great source of beta-carotene, containing 25 times more than is found in raw carrots, and this is transformed by our bodies into provitamin A. Furthermore, spirulina contains a large number of minerals and other trace elements: iron, potassium, sodium, magnesium, manganese, phosphorus, zinc, chrome, and selenium. It is rich in iron, with 58 times more iron than raw spinach and 28 times more than raw beef liver. Apart from vitamins and minerals, spirulina is rich in enzymes and pigments of phytonutrients that demonstrate a positive effect on health. The most visible pigment in spirulina is chlorophyll, a green molecule common to plants. The concentration of chlorophyll is 5 to 30 times higher than the seed of alfalfa, wheatgrass, and barley grass. The pigment that gives spirulina its blue cast is phycocyanin. This may be the origin of life common to both plants and animals.
The blue protein, phycocyanin, and its blue component micromolecule called phycobilin can play important role in a recent methodology for attacking cancer. This methodology is called photodynamic therapy.
Spirulina contains DNA-RNA nutritional supplement. Specifically, it provides extra dietary nucleic acid bases to help maintain the health, development, and function of the body. This superfood has the most remarkable concentration of functional nutrients ever known in any food, plant, grain, or herb. Spirulina is presented commercially in powder, capsules, tablets, flakes, and even as broth. For undernourished people in the developing world, spirulina brings quick recovery from malnutrition. In Western overfed food cultures loaded with unhealthy and nutritionally depleted food, spirulina can rejuvenate the human organism. On top of this, spirulina delivers more nutrition per acre than any other food on the planet. In addition to its high nutritional value, spirulina is a discovery that could aid the planet in healing the wounds caused by irrational development. Living in space will require self-contained, sustainable supplies of breathable air, water, and food, as well as self-contained methods to process and recycle waste. Since early designs left limited room for plants, scientists looked at microalgae. Spirulina seems to be close to fulfilling these ideal conditions. With its high photosynthetic efficiency, rapid-growing spirulina turns waste into purified water, nutritious food, and oxygen sufficient to support humans in space. With the goal of reducing the cost of food and oxygen transportation to the space station, NASA and other cooperative national space services are developing a controlled ecological life support system called CELSS, or CELS. Its purpose is to cater for oxygen and food to the astronauts, and also to recycle waste by using spirulina. A similar European program called MELISSA is being deployed by the European Space Authority, ESA.
So one of these important research projects for life support system is the so-called by the ESA, the MELISSA project. where Melissa are the acronyms from the initial letters Micro Ecological Life Support System Alternative. This research project aims to develop in the spaceship a variety of foods. Central point in this project is the development of spirulina as a main food for using various wastes of astronauts like urine, carbon dioxide, and at the same time to produce this microalga, the necessary components, the biomass and oxygen used by the astronauts.
CELS consists of 3 large tanks. The first one is the waste collector. The waste tank is heated to very high temperatures, turning it from semi-solid to gas. The gas nutrients, along with the carbon dioxide exhaled by the astronauts, are pumped into the second tank with spirulina and chlorella. As the alga grows, using sunlight to photosynthesize, it can be continuously harvested and turned into various food forms. At the same time, the production of oxygen supports their living environment. Special filters are used to clean the water from the second tank and store it in the third. A dedicated computer system controls all the production stages. The system best replicates the recycling methods used in the big biosphere of our planet. For a better understanding of how this works, let's take a look at a biosphere on a smaller scale. There are already several international commercial companies that launch biospheres for both educational and decorative reasons. The biosphere is a sealed spherical enclosure containing plants and animals in perfect balance within an aquatic environment. It is an elegant ecosystem on its own, teeming with plants and animals in equilibrium. The environment is specifically tailored to support numerous life forms from both aquatic and animal life, such as small snails, crustacea, small waterborne creatures, and algae. Algae in the biosphere help keep the water clean and provide oxygen for the opaiula, the scientific name for tiny red shrimps. Light helps microalgae produce oxygen and food for the opaiula, which in turn produce carbon dioxide and nutrients to enable the algae to grow. Unlike in their natural habitat, there are no predators in the biosphere, so the lifespan of shrimps is extremely long, up to 15 years. There are also small worms that live exclusively in the bed soil, and many microscopic organisms living in the water that help waste recycling. In nature, these tiny animals form an important part of the food chain, providing prey to larger predatory species of invertebrates and fish. The most visibly active members of the biospheric community are small shrimp-like amphipods seen darting wildly about. Apart from the larger animals, there is a vast population of small creatures inside the biosphere, including daphnia, ostracods, and copepods. They are the window cleaners and gardeners of the biosphere. Spirulina is an amazing total food. It contains over 100 nutrients. It is one of the most complete food sources found on the planet. But it is not a medicine. It is a dried, naturally balanced vegetable, so it can be of great benefit to many different groups of people.
We can say that spirulina is very important as a food because it's high nutritional value and also because its effects for protecting our body from various diseases. These effects can be summarized, first of all, antioxidant effects, antiviral effects, and third, immunostimulation effects.
When it comes to usage, it is recommended to consult your doctor or pharmacist. Spirulina is best known for its anti-aging, energy-boosting and health-maintaining properties.
Spirulina has also energy-boosting properties, since it contains all vitamins and minerals that we need for our daily vitamin requirements.
The amino acids that make up protein are vital to the human body. They help with the growth of muscles, produce enzymes and hormones, and also aid the immune system. Spirulina is an excellent source of protein, varying in amount from 60 to 70%. These proteins are biologically complete. They provide all 8 essential amino acids in the proper ratios, as well as 10 non-essential amino acids. The protein in spirulina can be of benefit especially to vegetarians, since they often have difficulties in getting enough protein, iron and vitamin B12. Spirulina's vegetable protein is water-soluble, and excess amounts of it are normally discharged from the body. In contrast, excess amounts of animal protein are stored as fat, and over time this fat may have an impact upon the body's blood vessels and coronary system. Spirulina is rich in GLA, or gamma-linolenic acid, found only in maternal milk and evening primrose. Published scientific studies suggest that GLA will reduce serum low-density lipoproteins, the bad cholesterol, and raise high-density lipoproteins, the good one. Human studies in Germany and India found a weight reduction effect along with cholesterol reduction. Research is ongoing into investigating GLA as a potential anti-cancer agent. GLA is also recommended for autoimmune disorders, arthritis, eczema, and premenstrual syndrome. Spirulina is the richest source of beta-carotene in nature. The carotenoids are powerful antioxidants, reducing cell damage within the body.
We need to protect our bodies from free radicals. Spirulina is packed with antioxidants, molecules that can protect our cells from free radicals and make our cells live longer and better.
Spirulina is highly concentrated in phytonutrients and is easily digested, making it one of the best anti-aging foods. As people grow older, they may eat less or fail to digest their food as well as they used to. Taking spirulina can help elderly people build levels of the healthy bacteria, like lactobacillus, in the gut, supporting the absorption of nutrients and stabilizing the intestinal flora.
Spirulina has many anti-aging properties. That's why we usually recommend it to the elderly people. Of course, it is important to consult your doctor before you take it.
Spirulina has a completely unique combination of phytonutrients, like chlorophyll, phycocyanin and polysaccharides that can help rejuvenate our bodies. Chlorophyll, often called green blood, purifies our bodies of toxins. It also has positive effects in helping people recover from fatigue and fighting allergies. Spirulina contains a large number of minerals and other trace elements, fostering the metabolic and cardiovascular system. For example, potassium and sodium are important for internal water management. Magnesium and calcium foster bone, teeth, nail and hair structure. Iron, fostering oxygen transport in blood cells, prevents anemia.
Diseases like osteoporosis or health diseases can be prevented by taking spirulina, which is packed by all these minerals which are very important.
First of all, I would like to say that I am a happy mother of triplets. I consumed spirulina for 10 years and I was still consuming during my pregnancy. Frequent blood exams during my pregnancy didn't show any lack of iron or any other elements. Therefore, I didn't have to resort to any other supplements.
Spirulina contains a broad range of valuable vitamins. The rarest is B12, or cobalamin, a vitamin required for numerous brain and nerve systems, but especially in supporting hematopoiesis. Spirulina powder balances RNA-DNA. It helps brain function and gives better mental clarity. This tiny alga is important for anyone wanting additional energy and antioxidant protection.
The conclusion drawn from the feedback we get regarding the consumption of our product is that while everybody is using it, there is an increase in consumption among the elderly, athletes, and especially among hard-working people.
Spirulina provides athletes with long-lasting energy and improved stamina.
We made an experiment and we used for a number of days, for 10 to 15 days, an amount of spirulina which, according to the literature, is beneficial to human performance and health. And we used this amount to 10 athletes, and after this particular period, these runners ran a long run. The result was surprising even to us, because we saw for the first time that spirulina administration increased the antioxidant status in the body dramatically, and also increased a little bit the performance. So we believe that the antioxidant formulas that are taken by the athletes, which is more or less are synthetic or chemical, can be substituted by an amount of spirulina every day, and this is probably the ideal formula, natural and physical administration of an antioxidant, which can help the body to increase antioxidant status and make the ideal amount of antioxidant constituents in the body in order to have better performance and health for the athletes.
What are the hidden expenses of food production? Governments and industries use economic methods which are not effective anymore. Perhaps they used to be effective when natural resources were supposed to be free and unlimited. But what dramatically increases the price of production are the costs added due to energy wastage, when agricultural products are at the manufacturing stage. Government subsidies, which encourage the unlimited use of water and soil, do not take into consideration the environmental consequences. Fast metal depletion and salt-bearing soil can hardly be restored. The ground is eroded, water layers are decreased, and the forests disappear. Pesticides and chemical fertilizers pollute water and soil. These chemicals are certainly harmful, but what is the medical cost? Well, it simply cannot be estimated. What is the cost of restoring environmental damage? Again, it can't be estimated. So let's turn to an environmentally healthy food revolution. The production of organic food like spirulina does not have any hidden expenses. Its consumption will improve health and reduce medical cost. Ecologically orientated cultivation does not pollute the atmosphere or the water. It does not erode the ground or destroy the forests. No chemical fertilizers or pesticides are used in the production process of spirulina. Production expenses come to only €10 per kilo. Spirulina contains up to 70% protein and can be cultivated in infertile ground unsuitable for other cultivation. It offers more nutritional elements per acre than any other food. Although spirulina reproduces itself in water, it uses much less of it per kilo of production. And this happens because water recycles itself. Water will be one of the most important natural resources of the future. Spirulina provides large quantities of oxygen. Forests clean 1 to 4 tons of carbon dioxide per acre from the atmosphere annually. Spirulina produces 16.8 tons of oxygen and consumes 6.3 tons of carbon dioxide. That is amazing. The increase in temperature due to the greenhouse effect will dramatically change the Earth's climate. Harvesting will be reduced due to very high temperatures and lack of rainfall. Worldwide food shortages are certainly possible in the future. Countries like China and India have already declared that spirulina is a national priority in food production. In practice, the global food production and distribution system creates hunger in a world of abundance. 2/3 of humanity lives in poverty and suffers hunger.
Spirulina can be used because its high nutritional value is produced now to various areas of Africa for attack malnutrition, because it is so easily cultured in the various native areas, various lakes of Africa. So nowadays there are various projects of UNESCO for the production of spirulina, so attack the malnutrition and also protect from HIV the local population.
Every 5 seconds, a child under the age of 5 dies of hunger or hunger-related diseases somewhere in the world. The question has been addressed by the United Nations World Health Organization through the creation of the Intergovernmental Institution for the Use of Microalga Spirulina Against Malnutrition. The IIMSAM is currently running pilot projects using spirulina around the world with promising results.
Of course, we are open to any suggestions. We will be glad to help the United Nations program for fighting world hunger. We have already been asked, and we are currently looking into it. We would like to contribute as well by providing our know-how to African countries in order to resolve the problem of hunger straight away.
Spirulina can stop this untold misery. Agriculture cannot. How can we use microalgae against the greenhouse effect? As Professor Fritjof Capra describes in his book The Turning Point, nature has a superior systemic wisdom. One natural environment consists of ecosystems inhabited by countless organisms which have co-evolved over billions of years, continuously using and recycling the same molecules of soil, water and air. The organizing principles of these systems must be considered superior to those of human technologies based on recent inventions. This respect for nature's wisdom is further supported by the insight that the dynamics of self-organization in ecosystems are basically the same as for human organisms. This forces us to realize that our natural environment is not only alive, but also intelligent. So how can this kind of respect be achieved? Well, we can change our attitude by using energy more efficiently at home and in the office, and by directing our efforts towards renewable power sources. Lowering emissions of carbon dioxide and CFCs by building algae farms near power stations. Emissions can be filtered through algal vats. The algae can then be harvested for oil, or dried to be processed into ethanol that can be used for fuel. Farmers should avoid buying agricultural products for which pesticides and chemical fertilizers have been used. In this way, the water which flows into the sea is protected from pollution, and oxygen production by algae is increased. Up until now, wind and solar energy have been feasible solutions. Hydrogen is one new promising prospect for slowing down the dramatic climate changes on our planet. For example, at Berkeley University, Professor Anastasios Melis has found a method to produce hydrogen from algae. If algae do not live off sulfur, which is part of the aquatic world, then the production of oxygen stops and the production of pure hydrogen starts. This is a revolutionary discovery. There are already cars that use hydrogen as fuel with zero pollution emissions. This is a very progressive step towards stopping CO2 emissions. This systemic wisdom is both intelligent and able to heal the planet's wounds. We must, as soon as possible, decode this wisdom in order to find solutions. Microalgae like spirulina are essential resources for both individual and planetary health and restoration. The oldest photosynthetic life form is here. It represents a return to the origins of life. We must act now to save the environment and preserve our blue planet for future generations.